Well, good morning, good afternoon, good evening, good night to everyone, wherever you may be, I suppose somewhere across in our lovely world, unless you're in space. But thanks for joining us live here for the one and only Serverless Office Hours. We are streaming on two channels. If Twitch is your thing, welcome on the AWS Twitch channel, or we're on YouTube on the AWS Events channel. My name's Julian. I'm a developer advocate. Talk about serverless here at AWS. And today we are going to be talking about upgrading Lambda functions. And we have two of my favorite experts to go through it all. Returning guest, Dan Fox, who seems to be the owner and runner of half of AWS, at least. Yeah, that's, in fact, there's nothing else to say.
Major exaggeration.
Yeah, certainly within the serverless realm. Yeah, definitely.
Exactly. Dan, the man, is the boss. For Dan, people who don't know you, tell us how you ended up doing what you do at AWS.
Thank you, Julian. I've been with AWS coming on 6 years now, so feeling like an old pro. Started as a serverless specialist and did a lot of work with Lambda, worked on the problem that we're going to be talking about quite a bit. And today I am a solutions architect manager. I lead our solutions architects who work on containers and serverless worldwide.
Cool, yeah. And there are a lot of solutions architects under Dan. So yeah, he literally makes sure that all the ship is running to make sure everybody gets all the good serverless stuff they need. And Brian, welcome to Serverless Office Hours. First-time guest. We were chatting just beforehand, and you said almost on Serverless Office Hours. So it hasn't quite happened. So super glad to have you here to join us officially for the first time. Brian, what do you do at AWS?
I feel like I have kind of two jobs. My day job, or my primary job, is an account solutions architect. So I'm a senior SA who's assigned to a set of customers in the CPG and retail space. And so I'm helping them think about how to leverage cloud to execute their business strategy, how to set direction, how to transform with the wave of AI and all that kind of thing. And then the other side of my job is being a member of the serverless technical field community. And so that's an area of depth that I got to choose. And so I got to go deep on services like Lambda, SQS, Event Bridge, think about event-driven design and that kind of thing. And so sometimes I'm writing content or I'm giving talks. Dan and I have spent some time at reInvent together talking about testing serverless applications and event-driven systems. So there's kind of two sides to it. I'm happy to be here.
Cool.
And our long-time reInvent partners.
Yeah, that's right.
The awesome duo, I love it. Now we get to get your wisdom on the live stream. Remember, if you are joining us live, we're a live stream. Send us your questions and your comments. We always love hearing where everybody is. Erie Edits, who joins us regularly from Twitch. Hello, Erie Edits. Welcome back. And Origil 1995. What a great time to have the show. Started updating Lambda runtimes recently, and it's a pain. So you see, you're in the right place at the right time. So yeah, we love to see where our global audience is, so let us know. And if you're watching us in the recording afterwards, you weren't able to join us live, but hopefully you're getting good information. And yeah, please send us any questions or comments async if you would like to. So, I mean, Dan, Brian, seriously, a couple of Lambda functions, you want to upgrade them, blah, blah, just go up to the console, click, upgrade runtime, you're done. Like, why is this a bigger issue? What are we talking about today? That was a silly intro, but yes, what's the problem?
Let's talk about the problem area for a second. So it's really, the problem is a software problem. This isn't necessarily a Lambda problem, but it's the problem of runtimes expiring basically and becoming deprecated. So all of the major language runtimes, if you look at Java, Python, Node, etc., put out new versions, minor version patches, and then major version upgrades. And the major versions are typically not backwards compatible in terms of a language perspective. And so you, as a software developer, it's incumbent on you to keep up with maintaining your runtime. And what happens is, if the runtime stop putting out updates, then all of a sudden your security becomes compromised. If there's a new bug or security flaw found in an old runtime, well, you become exposed. And the longer your software stays on that old runtime, the greater your security exposure. Now, Lambda is actually very polite. And one of the reasons that people really like Lambda is in Lambda will actually perform minor version patches for you under the seams or under the covers. And so you get the benefit of kind of riding along this train of minor version patches. However, what we won't do is we won't make major version runtime changes to your function. And the reason for that is the major version changes aren't guaranteed to be backwards compatible. And so if we did that, we'd probably break a lot of functions. And so it's incumbent on the customer. It's a customer's responsibility in the shared responsibility model to make those major version upgrades. And if you've got hundreds or thousands, tens of thousands, we have customers who have hundreds of thousands or millions of Lambda functions, it becomes a non-trivial task to try to upgrade all of those functions. So we have a solve for it now.
Excellent. So if I was using, pick a runtime, Python, I've got a Lambda function in Python 3.9. I know that Lambda is going to upgrade within 3.9, as I keep going, but it's not going to upgrade me to 3.10 or 3.11 or whatever's going to happen in the future. Now, there is also a cutoff time where Lambda no longer upgrades a lot runtimes for minor patches, I think, as well. And I think that's part of our deprecation schedule. So even though your Lambda function will still continue running, you're not getting that benefit of an upgrade. And so, I mean, that's just what Lambda at least gives you a little bit benefit out of the box. But I know I spent decades in IT operations, and upgrades and stuff is just a lot of work, and it's really non-differentiated heavy lifting. And when you go to the business and say I need to upgrade, and we're not talking about, oh, I want to do Python 3.9 to 3.10. This is Java 1 to Java 3000. My point is the jump is often huge when you're desperate to do something. And so that's hard. So we're in the world of AI. I gather that can help.
Absolutely. And one of the points that I want to make, though, is that we will never block invokes, or historically we've never blocked invokes. So you can run on the oldest node runtime. I think we have some like node 4 or 5 runtimes out there, like really old. We won't block invokes, but at a certain point, we will block your ability to update or create a new function on a runtime that's deprecated, and then eventually we block updates to encourage customers to get on a new runtime. So yes, just want to make that point before we get into the AI bit.
And we do intentionally let customers know that they're running on deprecated runtimes in a couple different ways. There's banners in the console, there's notifications that go out over health, and there's these windows that we're publishing in the documentation about, okay, these gates that Dan mentioned. You have time in between each of those to make the change, but it's not forever.
Yeah. I mean, to iterate that point as well, this isn't even we're talking about some of the things that Lambda helps, but if you're running on EC2, on premises, any cloud, on your laptop, on a Raspberry Pi, wherever else, containers, EKS, Kubernetes, wherever, this is the same problem. You got to upgrade your stuff, and it's a job to be done.
So identifying the functions is one point. So Trusted Advisor is a very good friend of yours. I also like to use now Kira CLI or Claude. It can invoke the CLI and then actually, query your account, and you can get your functions that way. So identification is kind of the first thing that you need to do. Okay,
and I suppose it's slightly different with Lambda because people may have more Lambda functions than they would necessarily have EC2 instances. Sometimes that scale, Lambda's great because you can have functions doing fewer things, but it means more functions.
Absolutely. And so we've been working on this problem for many years, and we haven't had a really good solution for it. I mean, we can talk about identification, we can talk about prioritization, we can give remediation tips, but until AI came along, we really didn't have a good solution for customers, and I'm happy to say that now we do. Brian, do you want to talk about AWS Transform?
Do I? So AWS Transform is kind of an umbrella of services. AWS Transform Custom is an agentic AI service that lets you apply changes to your code base according to transformation documents that are written. Now, AWS provides a set of transformations, but you can also write your own. You can customize whatever you need. So if you want to customize very specific internal code bases from one form to another, you can write transformations to do that. But thinking about it in the context of Lambda runtime upgrades, AWS has published managed transformations through Transform Custom that you can apply to your code. So you can install the Transform Custom CLI, and then you can kick off one of these managed transforms to upgrade Python versions, upgrade Node.js versions. Those are two of the ones we're focusing on out of the gate. I think we also have a Java one now that can upgrade Java. And it understands those runtimes in the context of Lambda. So they're not specific to Lambda, They can upgrade those runtimes in sort of generic contexts. But if custom recognizes that the solution that you're running it against or the code base that you're running against is Lambda based or has Lambda functions in it, it can recognize that and go through the necessary steps to do that upgrade. And sometimes that's code changes. Sometimes that's just changing your infrastructure as code template and then validating that your tests still pass. But it's this combination of a CLI that you run against your code base, backed by agentic AI services hosted by AWS that can give you this transformation power, I guess.
So are there particular Lambda isms, for want of a terrible term, for this, or is that part just of knowing that it's Lambda and so you need to update the config or what the infrastructure as code looks like? Or
so the models supporting Transform Custom understand Lambda. Lambda's been around long enough that the information behind it has been part of the training material for these models. That's supplemented by the AWS managed transformation documents that describe a little bit more specifically, like if you're in a code base that looks like this, it's a Lambda function. Okay. And so make sure you have your handlers set up correctly. Make sure that the code matches the runtime configuration of, for example, your SAM template or your Terraform template or something like that. Makes sense.
And I suppose something like Node, if you're going from Node, say 16 to 18, well, that's an SDK upgrade from 2 to 3. And so it knows that kind of stuff.
Absolutely.
Exactly. And so you start to pull that thread a little bit more, right? So what's actually involved in one of these upgrades? I mean, the Node 20 to 24 upgrade is a pretty big deal. That one is dropping the old callback style of handlers. You have to move to async, right? And so that can become a pretty significant code change. But it's not just code. It's also things like dependencies. Like some dependencies may be pinned to old versions, or they may not be compatible with a newer version of your runtime. And so whatever is making this change on your behalf has to be aware of that and be able to potentially swap out dependencies for you.
Cool.
And then there's the whole channel about verification, but we can get into that a little bit.
RG1995, hope you haven't messed up your name too badly, but yeah, there, your question's answered. What about upgrading the underlying dependencies, especially the custom libraries, as it causes conflicts? So excellent. Glad to know this can help. And I suppose GenAI I mean, you could do this function by function by pointing it at Kiro, Claude, Codex, whatever. But one at a time sounds like a pain. So, I mean, I presume because this is a CLI, the service is also for doing things at scale and in a repeatable, understandable way. You know, it's a bit more than, vibe coding it one function at a time.
I get that a lot. Like, why not use Claude? Why not use Kiro? And why not use like whatever GenAI, whatever GenAI, Codex, whatever I have. And you've identified the reason, Julian, because if you're doing like onesies and twosies, or even like up to 5 like Lambda functions, and you point your code, your GenAI agent at it, then you can say, okay, that is doable. But once you start getting past 5, you're into like 10, 15, 20, 100, you'll find a lot of rough edges pretty quickly. Unlike using really, it's the enterprise scale execution of Transform that really distinguishes it. And in particular, I want to answer the question. I think there was a question about like custom dependency libraries, and maybe we didn't touch on that like specifically, but like as you're operating at scale, you're going to run into rough edges like this. I have a custom dependency library in my organization that's specific to this function, and I want to replace it with a different version. And I want to make sure that that's universally applied across like all my developers. Well, what you can do is you can take one of our managed transformations and extend it. And then you can put specific instructions into that managed transformation that says, hey, my custom dependency library now should be upgraded to version X that's located in this spot. And then that transformation can be distributed throughout your entire organization so that you can create standards across the organization for how you transform code.
Cool.
There's a couple of different ways that you can inject that sort of guidance, right? Dan talked about extending and managed transformations. You can create your own custom ones from scratch. You can also inject, I think, what's called additional context. So as you invoke Transform custom, the CLI, you can give it additional detailed instructions. Like, for example, I want to target Python 3.14, and I'm using UV for package management. And that can be additional context that you just layer in as it works. And you can also give it guidance along the way. So you can pause it and say, hey, I see that you're doing this. I would rather you did this instead, and have it continue.
Oh, cool. So it's using the AI tools as we sort of know on a onesie twosie, but keeping that context and keeping that information. So it builds up a bit of a, I suppose, knowledge library or a brain to be able to get better at the next ones.
We call them knowledge items, actually.
Ah, much better way. That's why I'm not in charge of naming.
And that's literally what we do. That's the other interesting thing about Transform, is that it learns over time. Okay. And as it accumulates knowledge, it encapsulates that knowledge, and you can actually approve the creation of knowledge items. And so, maybe your first 5 transformation in your organization, like you have to adjust it, and you maybe want to inform it. But then your next 50 and your final 100 or 1,000, like each time theoretically it should get better as it learns more and more about your organizational standards and your preferences.
Okay, cool. I'm sure we'll get onto seeing it shortly as well. But one other thing, because sometimes people talk to me about these things, says, "Oh, that's it's enterprise only, and it's all for the big companies. I don't really need to care about it." But we've got some SaaS providers who literally can have hundreds or even thousands of Lambda functions, because maybe they have a separate one per customer. We've now got tenant isolation, which does help with that as well. But it's not unreasonable for some companies, especially in an AI era where you're running untrusted code, or you're taking in some input that's going to affect how the Lambda function is going to run, and you want to have different functions per customer. And how many customers you've got? Well, even if you've got 1,000 or 10,000, doing an upgrade after 5 years is going to be painful. And that doesn't necessarily have to be a big company with 1,000 customers. So when we talk about enterprise, it's I don't want people being put off thinking, oh, it's only for the big companies.
No, in my opinion, if you're doing double-digit function upgrades, like over 10, even over 5, it's going to help you. But definitely over 10, it's worth looking at. It will accelerate your workflow and just make your life easier.
And it helps you bake it into the rhythm of your software development lifecycle. Like, nobody wants to do this type of maintenance activity. Just change a runtime, and then you go through all the verifications, make a couple code tweaks, and then you're done. But multiply it out, and that's a ton of work. But if you can automate that chunk in a reliable way, you can be doing it more regularly, and you can move up and stay on the leading edge of Lambda runtimes. And so you're picking up performance and optimization benefits that the Lambda team is baking into some of these newer runtimes, rather than being on the lagging edge and just barely ahead of being cut off, right?
Yeah, just before your security team is bashing you, saying, these have to be sorted out by next week. You're like, oh.
Yep.
Okay.
Yep.
Cool, excellent. Well, where to next? I'm under your guidance.
I could show a little bit of a demo and just kind of give you a sense for like what it looks like.
Yeah, let's show and tell, and then we can come back and talk about it.
Can we switch to my sharing screen, or do I need to do it myself?
I think you need to share it again. I'm not.
Okay, great. Happy to.
Someone sets back up. And remember, send us your questions and comments. We do have a friend from Brazil, Daniel Habib. Welcome back again. And Iriad said he's from LA somewhere. So we've got LA and Brazil in the house so far, and certainly some other people as well.
Okay.
Cool. Excellent.
So, great. So I have a sample project right here, and I will invoke Amazon Transform Custom. So you can see I'm in my terminal, and it is a CLI tool, essentially. So you can think of it as a CLI tool that gets distributed. And all of this portion is free, basically. Your CLI, what you do locally is free. And then what the CLI does is it organizes you and then allows you to communicate with the managed service. So the managed service lives back at AWS servers. And I can look at my code base here, which is in Git, and then invoke the CLI and then actually perform some stuff on it. So let's see, create transformation.
So it's proper sort of chatbot style. It's not even selecting menus, anything.
It's a chatbot, and you can use the chatbot. You can chat with it, non-deterministic, and so you can have different types of conversations. And let's see, create transformation. What kind of transformation? Tell me about AWS managed transformations. So as Brian and I mentioned, AWS has a number of managed transformations that we manage. And I think in the show notes, actually, we've linked to some, so you want to see what that looks like. So you can use our managed transformations, list them. I said let them. So you can use our managed transformations, or you can actually extend them and create your own transformations as well. So we have a lot here at AWS. I think we're up at like 500 internally, but I think we have 9 or 10 managed transformations. Does that sound right, Brian?
Yeah, something like that. The list keeps changing.
Yeah.
So just quickly, as you mentioned there, we've got lots of transformations internally. So this is obviously something we're using internally at Amazon. This isn't just a YOLO weekend project that we're putting out there and hoping people are going to use it. This is, Amazon ships a little bit of software, I can imagine. So if we're using it internally, it's got to be, pretty heavily used.
Absolutely. You can see we've got 555 internal transformations that we've created.
Wow, so it's like ZOS assembler to Java 21. That's got to be a fun one.
Yeah, exactly.
So I'll look at I think the first 13 of these, I guess, are the AWS managed transformations. So here we go. And if you look at the show notes, I think we have links to all of these so you can take a look at them. But like, let's say I probably want to do the Python version upgrade. So I'm going to say just 4 here. And then it's going to guide me through a process. So first it's going to identify the transformation. It can be applied to your code. Would you like this applied? Would you like to apply this transformation to your code? Yes. File path dot. So I'm in the folder that I want to work on.
One thing you'll notice from that list, right? We talked about being able to create custom transformations. You can then publish those custom transformations to your organization, and that's kind of the vehicle through which you can share to other teams, other organizations, other sub-organizations. So it all ends up in this registry that your teams can then log into and pull from.
Okay, so at this point, I have told it the transformation that I want to perform, and I've told it the code base that I want to point at. And it's managed by Git right now in my file path. And so now it says, do you have any additional preferences I should take into consideration beyond what's described in the transformation definition? So now if I want to modify the transformation or extend it in any certain way, or if I have a specific requirement that I want to put in, this would be the time for me to tell Transform Custom, hey, in addition to the transformation that you chose, like also perform these steps. But right now I'm just going to say proceed. So that's proceeding with defaults. And the first thing it's going to do is it's going to create a plan. So it's going to look at my code base, go through it, look at the transformation, and then determine what needs to be done. So it's not going to perform the transformation without me asking, but it's going to create a comprehensive plan that I can then review.
And obviously, if you've even got some, markdown file or whatever with some other instructions, you could also say, point it to this markdown file and, get some other stuff, whatever. This is just context in an AI tool, as we've done with lots of other tools.
100%. Now, before you do a transformation, Amazon Transform Custom will create a plan for you. And we can see the plan in a little bit. But also, we have a transformation, a managed transformation that just performs an assessment. Its whole purpose is to actually just look at a very complex code base and perform an assessment so you can actually bring the complexity to maybe your peers or your boss and say, okay, here is the complex code base that I have, and it produces I think 33 different files, Brian, on assessing a complex code base. And that might be a good thing to show, Brian, before while we're waiting here.
Sure. I think, Julian, if you wouldn't mind switching to my browser here.
Whoops. Go for Jeffrey. Jeffrey, our awesome producer. I'm stepping on his toes.
Thank you. So this is the list of available AWS Managed Transformation published through the docs. And the one that Dan is referencing here is the comprehensive code base analysis. So you can run this transformation, and it does exactly what it says on the tin. It goes through the code base and produces an analysis, static analysis of things like dependencies, things like version version compatibility, things like structural risks, potentially architecture analysis, all these kinds of things. And so we've run this analysis on a sample code base. And so this is the type of output that you get. Now, what it actually prints is a bunch of markdown files. And so you can look at it in that version. We ran those through a conversion tool that converts that the markdown to HTML. So it's a little bit easier to browse. yeah, generated by Kiro CLI naturally. And so we get sections like this, like an architecture. This is a system overview of the solution. It's Python. It noticed the version. It noticed that it's end of life, and it immediately sends us over to the tech debt report, which we'll look at in a second. But it noticed that it's Lambda. It noticed a couple of other components that are involved in this thing. It found our tests, which I'd like to get back to in a little bit there. It found the deployment model. How do we deploy these things? And some of the patterns involved in the solution overall, right? This is all output from running that transformation against our code. And so it found the different components and even drew us a ASCII art diagram of the overall architecture.
One of the things that I find a lot of customers, maybe they're not the authors of the original functions, right? And so sometimes they walk into a project and somebody goes, well, you have to upgrade this application. And they're like, well, I have no idea what it even does because I didn't code it. So this actually helps you by helping you understand what is the architecture, what are the main architectural components, what is it composed of, and then actually what is the tech debt that you need to assess.
Cool. And I think Argy says also, is the tool intelligent enough to list the outdated libraries? So I just saw something there about Boto 3, for example. So
yeah, let me see.
Yes. If you go to the tech debt section, Brian, it's a little bit down. Oh, well, there's dependency analysis, of course.
So this is the dependency analysis, and so it talks about what dependencies are in place. Are we pinned or not? Where are they being pulled from? Internal modules, potential version conflicts, and then known deprecated dependencies right there. And so this solution is one example of having a deprecated dependency. It's part of the mocking libraries. So the tool is able to notice that and surfaced it. So that's one of the reasons why, at least I like running this. First, you get a feel for, okay, what am I biting off in trying to transform this? And is it just going to be that infrastructure as code switch, or are we replacing dependencies, and what does that look like? And is it a major code change or not? This can kind of give you a feel for how big of a challenge you're about to take on.
The piece that I think is, so if you imagine you have hundreds of functions or thousands of functions, I think the tech debt set of reports are really, really interesting for that use case. So you can see here, it will assess the tech debt and say, these are your high risks, these are your medium risks, and these are your low risks, and outline them for you. Now imagine that I've got like hundreds of functions. I could actually look at the tech debt summary and then use this report to prioritize. Like, okay, well, this is a very high priority Lambda function because the tech debt is pretty severe, and maybe I should prioritize that first. Otherwise, like maybe this one has pretty low risk and it's not a big deal. So this is something that can help you at least prioritize like where you're going. And let's look at the other reports really quickly, Brian, because it has there's 5 there that are really interesting. The outdated components, maintenance burden, and remediation plan in particular.
Outdated components. So it talks about the Python runtime, high severity. We need to get off that thing. And then some medium and low severities, the dependency, unpinned Boto, and similar, right?
Yeah. And then, the remediation plan. Yep. So this will tell you like what it would do, what you recommend, what it recommends that you do. And you can use this remediation plan also as an input into the transformation. So if you really like this remediation plan, you can say, make sure to do all of these steps as well as the steps that are included into the Python transformation that AWS manages. So
cool. I mean, while we're looking at this, we've done it sort of at one app, but I mean, in a monorepo setup, or if you have multiple functions in a folder, would you do it function at a time? Or what are your thoughts on that?
I pointed at the base of a project, basically. the root of a project and just say go.
Okay.
Yep.
May sound weird, but I know internally, as Dan said before, when functions keep running. We've got customers running functions. They don't even know what the functions are. They may not even have the code. And I know now within the console, at least, you can download a zip file of the function. It's not going to quite work for something that's compiled or that kind of thing, and download a SAM template for that as well. So I suppose just to start off, generally you need to have the code for this as well. It's not just going to go into your Lambda console and work this out pointing just at your console or Lambda on. But there are some now ways that you can at least download the code and maybe grab some Lambda configuration stuff, which will then spot the triggers and all that kind of thing. So you could do, I suppose, a bit of archaeology to come and figure that out. Because it may sound flippant, but I promise you there are many people out there running Lambda functions that nobody knows what they do. They're obviously critical, or maybe not, but they don't know. Yeah, you got to get yourself out of even a deeper hole that you dug yourself in.
For sure. Yeah, I think that's a very good point to make. We are not going to operate on your behalf. We're going to help you solve the problem, but we're not going to go into the Lambda console and make these updates for you. How we've designed this is we want it to be compatible with your process. And so the way that it works is that like Transform will look at a Git like a repository, and hopefully it's managed via Git. If it's not, then we encourage you, as Julian said, to download your code. If it's just in the console, download the code, put it into a Git repository. And then what Transform does is it will actually very politely look at all your code, and then it will create a branch. It doesn't just like overwrite your main line. It will create a branch, and then it will perform all of the transformation operations on that branch, so that if you wanted to, you could push that branch into your CI/CD pipeline, run a PR or an MR, and then have it be reviewed and then move through the pipeline within your company. So we want it to be a polite citizen. We want you to follow best practices, and we want to align it with the processes and protocols that you probably have in place in your business.
And that kind of gets to the responsible AI aspect of how we as an organization are approaching all of these things. So along with it being a respectful or polite, I like the word you used, Dan, the polite citizen, respecting your process, there's also transparency. So you get the full log of all the work that Transform is doing. Sort of its thinking or reasoning process is all dumped out on the machine that the CLI is running on, as well as all the artifacts output. So you can go and review that. You can understand what worked, what didn't, what choices it made, and why. That can be kind of a transparency tool. It can also be a learning tool, like, hey, we need to tweak our transformation because it keeps running into this error, and we need to give it a little bit of guidance, make it more efficient. So that kind of gets to the idea of it being that responsible citizen in your world, right?
In fact, I can show the files that you mentioned, Brian, because the plan just completed.
Oh, cool. Yeah.
So can we switch back to my presentation, or do I have to?
Yeah, if you just share it again,
okay,
Dan, we can stick it up.
Yeah.
And also, yeah, just a comment from Elsie Dharma via YouTube. I think that could be Leandro, maybe. And the functions have millions and millions of executions. Customers no idea what's there. Transform can help a lot with that, especially with this reverse engineered knowledge base. Because yeah, there are. I mean, it could be a web app or could be some asynchronous processing. Lambda functions can be running at ridiculous high scale, and people are terrified to touch it because you just don't know even what's there. And so, hopefully, using this, as Dan says, a good option for a CI/CD pipeline with another version or this kind of thing, and you could at least try and tackle that nut.
100%. Okay, so as you recall, what we did is we looked at the transformation definitions. Then we picked the Python AWS managed transformation definition, and then we applied it to the code base, at the directory that I'm in. And so what Transform first does is it tries to create a plan. So it goes through, it looks at the managed transformation, and it looks at the code base and says, okay, here's the summary of the plan, right? So the project is called AWS SAM Python CRUD sample. The source version is Python 3.8. The target version is 3.12. And then it has a plan overview. So this is not the specific plan, but this is kind of like the basics of the plan so that I can kind of understand basically what it's doing. It's going to set up the Python 3.12 virtual environment, update the project configurations. It is going to update the test files so that there's tests in here, so there's more modern compatibility. And then finally, it's going to perform a validation. So this is a really interesting part of the protocol here, which is that if you have automated tests or some kind of unit tests or included in the project, you can specify a validation step. So then what Transform will do is it will go through, it will transform your project, and then it will try to perform those validations. And if it determines that the tests, whatever validations you specify, and it will see embedded tests and it can just use those. If your tests fail, well, then it's a failed transformation. But then if it passes the validation step, then it calls it a successful validation. It has more confidence. You can have more confidence the transformation was ultimately successful.
And to add to that a little bit, it runs those tests as a part of the process, build steps, build commands, test commands, and it will try to course correct based on the output. Like it'll run a build and then it will see an error and it says, oh, I forgot to include a dependency, and it will go add the dependency or swap it out, right? So it's not just I do all this work and then I check it at the end and then I either pass or fail. It checks its work along the way and it uses that to help course correct. And then as a final sign-off step, it goes through its final criteria, runs those tests like Dan was saying, and then does a couple of the other checks that are embedded in the transformation definition, and then decides pass or fail by the end.
So is that now, because the stuff we've been running at the moment is locally, is that then within, the run the thing and it happens in the cloud? Is that what the managed service then does? So it actually builds it as part of the service on, I don't know, code build or some equivalent of like that, does all of that. I suppose it can create if you don't have the tests, it can also create tests and do that kind of thing and mock an input payload or things like that.
The tests and build commands run locally wherever, well, I won't say locally, wherever the CLI is installed.
Okay.
And we can get into, well, there's some solutions for scaling and that kind of thing. So not necessarily on your developer machine, but it runs them locally.
Wherever at least it kicks them wherever the CLI is installed, basically.
Exactly. But those build commands it's running a CLI script, right? So those can do things like deploy stuff to the cloud and run integration tests and all that kind of stuff. It depends on how much you've invested in your validation suite for it to be able to take advantage of that.
And Julian, as a customer, you don't actually want those tests running on agent's time, because what you're doing is you're actually paying for agent time. You're not paying for wall clock time. You're paying for agent time. And so when the agent goes and makes transformations, like you pay for that time. But then if you want to run tests, you can do all those things locally. If you're moving files around, all of the local stuff, you don't get charged for.
Yeah, you don't want to be paying an AI model to do your CI builds and do all that kind of thing. That just seems crazy, yeah.
No. So Brian was talking about some of the logging that this does, being a polite citizen. So you can see here that the plan.json file is saved as an artifact in the artifacts directory. So if I wanted to review the plan in more specific detail, I could look at the very detailed plan there, and I have a history of it. Also, this conversation history is changed in my local logs too, is put into my local logs too, so that I can resume another conversation history and pick it up or start a new one, and all of that's logged here. So at this point, it's asking me, are you ready? Like, here is the overview of the plan that I'm going to create for transforming. Do you want to revise any part of it? Do you want to look at the plan? I can edit the plan or make modifications, or I can just proceed. And at this point, I will proceed. So now it's going to go into the main kind of portion of the transformation, and I can follow it step by step. And I think this one takes about 15 minutes, Brian?
Yeah, something like that.
So when we talk about performing these transformations, now you're seeing us go through an individual function transformation. And this is good if you want to establish best practices, you have a high judgment situation. You might want to do these for the first few. And then once you start establishing some precedents, some organizational standards, running into common problems, then you might want to start extending your transformation definition to include those. And then at a certain point, you're going to say, okay, I'm ready to do 50 functions, 100 functions, 1,000 functions. And you wouldn't do it this way. Brian, do you want to show how we would use batch and Fargate in order to do function transformation at scale?
Yeah, let me pull up that section here.
So I'll just talk about it conceptually while Brian's getting it ready. So as we mentioned, we distribute the CLI, and now I have the CLI on my local desktop machine, and I'm performing a transformation that's actually occurring back in the managed service. But if I wanted to do 1,000, let's just say 100 transformations. I can certainly do 1,000 too. Let's say I want to do 100 transformations. I don't necessarily want to do them all concurrently on my desktop. And so instead, what I'm going to do is use Amazon AWS, I'm using batch and Fargate to actually be sort of like the controllers for all of these transformations. And I can feed into batch exactly what I want to do, and it will tell Fargate to do that. We have a container image in ECR that's public that Fargate can pull down that contains the Amazon Transform CLI. So the Fargate will contain the CLI, will instruct Fargate what to do, and then it can go on without us.
So that then becomes the compute environment, the local environment where you
that's
actually
that's the local environment where all your tests get run, all the files get downloaded. If you want to download a GitHub repository, all of those things get done on that Fargate environment.
And has the build tools and Python versions or whatever Java.
Yes, all of those.
Yep.
Correct.
So the interface to that control plane API, which is implemented as an API gateway, REST API, you can pass in instructions to transform a specific repo or a set of repos. So you pass in things like what transform to apply and where to find the repository. That gets coalesced into this AWS batch job queue that then Fargate compute environments get spun up on the fly to respond to these transformation commands. And like you were saying before, that Fargate task is the compute environment that's actually running the ATX CLI. And there's a command line switch that you can add. Well, there's a bunch of command line switches, but one of them is to run in headless mode. So you can, Dan, when he was showing the ATX CLI, it was in chatbot mode. So you're going back and forth, giving it instructions and that kind of thing. You can also run it in headless mode. So it takes the transform you've chosen and any additional context you pass in as a part of the run command. And then it just goes. It assumes yes to everything. But it still does the work of creating a branch and respecting the same software development lifecycle process. So you get your transform code as output in S3. It doesn't go and overwrite main branches anywhere or anything like that. But you can import it then from S3 in that way.
Cool. And I see 256 virtual CPUs, so that should crunch through as quick as it can.
Yeah.
I think the default is 128. Maybe that's the default Fargate configuration, Brian.
Yeah, I don't remember off the top of my head, but yeah. We can crank it.
I think the point I want to make is that you can go past 128 concurrent environments in 256 vCPU. The limitation here is basically your quota.
Yeah.
So we don't have a specific limit for Transform specifically. The limitation is going to be on like how many Fargate concurrent instances can you create.
And this is depending on how much concurrency you need. I mean, you're also welcome to do 1,000 async and just run it through. I mean, you haven't upgraded these for years anyway, so let's be real.
Yeah.
Right. How big of a hurry are you in?
Exactly. Cool. So I suppose workflow-wise and fitting this into existing workflows and existing patterns. I mean, is this sort of understandable stuff? People are doing CI/CD things anyway. You could theoretically bolt this onto some of your CI/CD pipelines, and do try and get to some more automation for upgrading these. Yeah. What's the story with fitting into how people do things already?
100%. So Maybe Brian, you can navigate to the module 3 in our workshop, and we can talk a little bit how you might want to think about bolting this into a CI/CD pipeline. So imagine that you have that you want to upgrade Lambda functions on a regular basis, right? And you would like an agent to wake up from time to time and then either perform an assessment or actually just perform a transformation and submit a PR into your code base without like a human. You want a human in the loop, of course, to maybe merge your PRs and see what's going on. But like through this, you could theoretically have an agent that just runs on a periodic basis, perhaps quarterly, perhaps monthly, however whatever you feel like your security needs, best serve your security needs, and then just perform those upgrades and submit PRs. So let's look at the command, Brian. Let's see. Assess. There you go. So right here, you can see this is the command that we're using to actually invoke the batch and Fargate.
Brian, can we just zoom in a little bit? Sorry.
Sure. Yeah. Let me make a little bit more room. How does that one look?
We have a little bit of a utility file. You can download it yourself if you don't have it, but it's open source. And then we invoke that utility file. We pass it in a batch name, and then we pass it in certain specifics about the job. So each one of those source lines contains a GitHub repository, as you can see, and then it has a command, right? So it's the ATX custom CLI command, and then you name the assessment that the transformation definition that you want to do. So in this case, we're doing the AWS / comprehensive codebase analysis assessment. And then if you go farther, you can see, no, I'm sorry, there's a couple flags there that I just want to make note of.
Yeah.
The X and the T. So the X and the T are basically informed. The X is like, I want to perform in headless mode. I don't want it to be interactive. I want it to just execute. And the T is a trust command.
And you can see those are very different ones. I mean, you can see one is a Spring Boot, one is a to-do app, one's Lambda nodes. I mean, these are also very different apps.
Absolutely. And you could put different transformation definitions. Each line could have a different transformation definition. So what you might want to do in a very complex code base is first perform the comprehensive code base analysis on all of your software. Then that will produce a number of different reports, and the reports will also recommend which transformation should be done on the code base. So you could take the output of the assessment of the code base analysis and make that be the input of your batch process. You could easily wire all these things together and make them and automate them.
Yeah. And to that point about automation and how it fits in the development process, Julian, you mentioned that earlier. It's built to be a good citizen. It's built to respect your process. Like all automation, though, it benefits from two things: testing, robust test coverage and validation capabilities, and as well as observability. So you can do all this upgrade sort of blind, but if you have test coverage, you get confidence out of behavior is not going to change. This upgrade that I applied still passes all of the tests. My system still behaves the same way. And if you have solid observability on the other side, once it's deployed through whatever your deployment process is, maybe it's a pull request, maybe it goes through CI/CD, maybe it's a manual deploy, whatever it is, you can catch if the upgrade impacted runtime behavior and then roll it back, right? Or respond in some way, raise a ticket and come in and bug fix. And so it's not unique necessarily to Transform Custom, but building automated code delivery benefits significantly from both of those two validation approaches, right? Preventative on the test side and then observability on the tail end. And Transform Custom can even take advantage of the test coverage by running it as a part of the Transform.
Brian and I are automated test nerds. Spend more time on automated testing than probably want to talk about and not feel
even just a shout out, because on Serverless Land, there's a whole sort of testing section over there, which I know, lots of people have contributed to, and Dan spearheaded that as well. So yeah, we've got lots of stuff there as well for doing testing, because it's one of the forgotten things until it's often not too late, but late in the day.
Right. Brian was my co-host on that testing project. So.
Awesome, Brian.
Yeah, and so organizations that invest there can see the sort of velocity improvement out of this kind of tooling, right? Like it's harder to use effectively or to the maximum extent possible if you don't have some of that investment in your code base, both on the observability
and I suppose nowadays in the Gen AI world, it is so much easier to write tests as well that, before, if you were behind, it's like, oh, seriously, am I going to have to write all the tests before I can even do the upgrade?
Yeah.
And I'm going to miss out all the tests and, whatever. That's what AI is super good at.
Super good. Yeah.
Yep.
I want to cover just a couple things. I know we have just a little limited time left, so I want to talk about maybe cost for a few minutes, and then I also want to plug the workshop that Brian and I are doing tomorrow. So, Brian,
this isn't free?
It's not free, but it's. I think it's pretty worthwhile, pretty valuable. Brian, do you want to go to module 1 and we can look at the cost analysis?
Yeah, I'm happy to do that. Cost, time, and scale. Here we go.
Okay, so this is So basically, the cost to transform the CRUD that you saw, the project that we kind of started transforming. We previously run this in the workshop, and so the wall clock time to transform it is about 28 minutes, right? But the agent minutes consumed are less, or no, I'm sorry, more.
Yeah.
Sorry.
Yeah, because they run in parallel, right? So you may be waiting for ATX to do its thing for 28 minutes, but it may be running sub-agents in parallel, and then the minutes consumed by all those parallel executions of sub-agents.
Right.
And totaled up into that agent minutes consumed final number.
And this was for the assessment. This is the one that produced the 33 markdown files.
Yep.
And so it was basically about 5 minutes, $5 to produce those 33 reports.
I like this page because it calls out capping spend with limit. So in the case that you're managing budget over time, you can use that limit command line switch to be able to say, I'm willing to invest this many agent minutes in this effort, but no more. And so that can sort of map into your financial strategy as well for some of these automation tools. Module 2, I think, has the actual transformation numbers in it.
Oh, right. This is the one I thought we were looking at earlier.
Yeah. So this is comparing manual upgrade to automation, right? So depending on your developer compensation and how much effort it takes them to go through this type of both transformation and validation work compared to Transform Custom, you can see significant savings both in cost as well as time, especially when you start to get to scale.
Yeah, so just like as a kind of an order of magnitude so you can understand, like this project contained about 5 Lambda functions. Is that right, Brian? 5 Lambda functions?
Yeah, I think, yep.
And so it had one SAM template, 5 Lambda functions, all the embedded code, and then all the dependencies for $1.58.
Yeah, $1.58. So the analysis is more, and $1.58 to basically do the transform that's a third of a cup of coffee or something. So that seems like a good use of time and tokens.
If this is interesting to you and you want to learn more about it, Brian and I are hosting a free workshop. There's one tomorrow and then one a week from Wednesday. I think we put it in the show notes. I have a LinkedIn post to it, but you can register. Again, you can come for free, and in it, we will be going through this workshop. So we've kind of touched on some of the highlights of this workshop. We'll go through the workshop in more detail. We give you your own AWS account, so you don't have to you don't have to incur any costs, and we'll pre-deploy a lot of these assets on your account, so you can actually don't have to go through a lot of the configuration too. We're trying to make it as easy as possible, so that you can just run through the workshop and really, gain an understanding for how these components work together, and then bring really concrete understanding and some materials to your own situation, so that you can perform the transformations. Bring that knowledge back to your own enterprise or your own company and be the expert there. So please join us.
It'll be fun.
Fantastic. And just some other things I was thinking about while you were chatting is, we are talking about a sort of, I don't want to say narrow, but a sort of vertical use case, I suppose, of upgrading Python or Java or that kind of thing. But I presume that the concepts, and because it's AI built, it can do lots of migration and modernization facts as well. If you were switching between infrastructures, code tools, for example, or even deciding you have a node function or a Java function and you want to move it to TypeScript or that kind of thing. I mean, I presume this is all AI coding. It can figure all that stuff out. So it's not just, I need to keep going on the same train tracks. You could decide to do a whole bunch of different things, or introduce infrastructure as code, or say I'm using TypeScript, I want to use a CDK, but I was using I don't know, CDK for Python, and I wanted to go to the Terraform, for example. I mean, I suppose this is all possible. You can do any sort of those, because those modernization, migration things are also quite a pain. And of course, runtime upgrades is part of the story, but there's a huge amount of stuff you want to maybe optimize or maybe change, or maybe you want to use, EventBridge instead of SNS, or you want to use, AppSync, AppSync events rather than, I don't know, IoT Core or something, so I suppose I'm thinking wildly here, but there could be a lot of other kind of things you could do that. And previously you could do it one-on-one in Kiro or Claude or whatever. Now this is a really structured way that you could do a whole bunch of cool migration things as well.
100%.
You can work through the definition of that transformation. Maybe it's a framework change. I think if I remember right, one of our managed transforms is Angular to React, right? Like you can do that sort of framework change. Architectural changes are an interesting one because you can express architecture as code through CloudFormation, Terraform, and that kind of thing. You can use a tool like this to transform that architecture. It's expressed in code. So you can analyze it, you can transform it through the expression of that infrastructure as code template. Definitely.
We're showing you a very narrow slice of Amazon Transform Custom. But, Amazon Transform has much more to offer. We have VMware containers, we have mainframe modernization, we have Java upgrades. Like there's a lot to this, and we're just kind of giving you a narrow slice. But if you're interested in transformation for modernization, migration or modernization, there's a lot more to learn.
Cool, excellent. And just Leandro came back and said AWS Transform is now available in Kiro as a plugin. That's really nice because you can run that in your environment and then use Kiro for fine tuning, for example. And I thought when we were doing the whole sort of chatbot kind of thing, I thought, that'd be great to have it in an interface where you can see the markdown files, and Kiro is all about spec-driven development as well. What is this? You're creating design requirements, a whole spec in effect for transformation. So I think the two would work great together.
Thank you, Leandro.
Leandro is always awesome. Absolutely, always awesome.
It's a Kiro Power, actually. I believe it's really useful.
Cool. And I suppose that some of the takeaways is Transform is very customizable, and it's about teaching your organization, or getting AI to teach your organization learnings over time. So you start up sort of like a boulder rolling down a hill. It starts really slowly, and you can build up the organizational knowledge. And then speed up and go nuts and try all these things out, and it's a structured, opinionated process. Is that the sort of wrap up of the cool things you can do?
I think you nailed it, and that's something that you can scale to your organization, right? Like there's infrastructure around it that lets you do the knowledge capture and sharing afterwards, right?
Cool. Anything we've missed or we haven't spoken about, which is top of mind?
I don't think so. I think we've covered the main points. For me, what I'm really excited about is I think we are used to understanding Gen AI for the use case of like greenfield development. But I think really the new frontier of AI, like what we're seeing at AWS, is actually the code transformation aspect of it can be just, if not more powerful, considering how much technical debt people already have out there. So exercising Gen AI to perform these transformations is a really, really interesting new frontier.
Yeah, just even on that sort of planning process, things like Kiro, when it's doing that initial analysis, it's awesome to use AI tools to say, well, what are the modern approaches for this? How should I think about upgrading that? That library's been deprecated, but are there better approaches for doing this? And so actually having a whole sort of AI chatbot experience just to create that, what have you got and what you can get to, and then you can hand it off to custom to do stuff. So yeah. The Gen AI world is exciting. Well, excellent. Brian and Dan, thanks so much for sharing your awesome knowledge. Please jump on the posts to do the workshop if it's of interest for you. And happy upgrading your Lambda functions. Bye-bye, everybody. see you next week. Same time, same
Thank
place.
you.
Bye-bye.
Thank you.